Good morning, children. Today we are starting with the Science and Technology Part 2, Chapter number 18, Observing the Spaces. So, we all know that 400 years after Galileo used the telescope, tremendous progress has been made in the telescope technology and in the space science and the technology on the whole. This great leap in the technology has helped to understand the universe. Space science and technology are not only important for research purpose but also for the help provide us comforts and facility. A telescope can be used to observe the space, but why only we need different types of telescope for that purpose? We all are going to study these things in the present chapter. So children, for understanding the telescope, first you have to understand different forms of light. What is light? Light is nothing but it is an electromagnetic wave. Okay, our eyes can see only the light which has wavelength between 400 nanometer to 800 nanometer, and such light is called as the visible radiation. However, there are electromagnetic waves of wavelength other than the visible eyes, most of which we cannot see as our eyes are not sensitive to them. This is a table, children. It is given in your textbook, and here it is mentioned that what type of radiations you can see in the different type of the light waves. All of the above types, our eyes are only capable of seeing the visible radiation. Thus, we use the visible radiation of telescope. That is, optical telescopes are made from the regular lenses to see the visible radiations coming from the space. However, many heavenly bodies emit other radiations that are other than the visible light. Thus, we need different types of telescopes like X-rays, gamma rays and radio telescopes to receive such type of radiation and study their sources. In this chapter, we are going to study about the telescopes and how are they used to watch the atmosphere. Good morning, children. Today we are going to study about the telescopes. The optical telescope. These are the different types of telescopes. A refracting telescope is shown. Most optical telescopes are made up with 2 or more lenses. It is shown in the figure in your textbook, chapter 18, figure number 18.1. To collect the maximum amount of light coming from the heavenly object, the objective lens should be made as large as possible. Using the light collected by the objective, a smaller lens called eyepiece produces a larger image of the source. The light rays changes their direction as they enter a lens from the atmosphere, and again when they enter the atmosphere after passing through the lenses. This is called the refraction. Hence, such telescopes are called refracting telescopes. Even though such telescopes is useful in space observation, in present there are certain difficulties. As we saw above, if we wish to obtain a bright image of a source by collecting the maximum possible light from it, the objective lens must be as large as possible. However, it is very difficult to make very large lens. Also, large lenses are very heavy and they tend to get distorted. As the objective and eyepiece are placed at the opposite ends of the telescope, the length of the telescope also increases with the increase in the size of the lens, and the telescope becomes difficult to manage. This image produced by the lenses have errors in this color, and this is called the chromatic aberration. And these are the difficulties which we have discussed in handling the telescopes. Now children, to overcome these difficulties of the refracting telescopes, we are having another technologies that we are going to discuss in the upcoming videos. Good morning, children. Children, today we will be studying about the reflecting telescopes. To overcome the difficulties of the refracting telescope, telescopes are made using the concave mirrors. As the light rays get reflected by the mirrors in these telescopes, these are called the reflecting telescopes. In order to get a bright image of a source, large mirrors are necessary so that they can collect a large amount of information from the source. But it is easier to make large mirrors as compared to making the large lenses. The reflecting telescopes are mainly of two types, Newtonian and the Cassegrain. This is the picture of the Newtonian type of the telescope. As shown in the figure 18.2 in your textbook, the light rays coming from the space are reflected by the concave mirror. Both of these reflected rays converge at the focus and they get deflected again by a small plane mirror. As a result, they get focused at a point lying on the perpendicular to the axis of the telescope cylinder. They pass through the eyepiece and we get magnified image of the source. And hence, we are using the reflecting type of the telescopes so that we can get a large magnified image of the source. And even though the problems which are coming in the refracting type of the telescope, as it is discussed in the earlier, those problems can be get sorted. So children, now you might have understood that the reflecting types of microscopes are of two types, that is Newtonian and the Cassegrain. Now Newtonian types of the telescope we have discussed in this video, and in your upcoming videos we will be studying about the Cassegrain type of the telescope. Children, please refer the textbook, read the lesson, go through the videos so your concepts will be becoming more clear. Good morning, children. Children, today we will be studying about the reflecting telescopes, and in that we are going to study about the Cassegrain telescope. The construction of the Cassegrain type of telescope is shown in the figure 18.3. The Cassegrain telescope also uses a concave mirror. However, here the light rays after reflection from the concave mirror are reflected backwards by it and in a small convex mirror. They pass through a hole at the center of the concave mirror and then through the eyepiece situated at the back of the mirror. The eyepiece gives us a magnified image of the source. In India, we are having several telescopes with concave mirrors. The 2-meter diameter that has been used for many years. The biggest optical telescope in India is having a mirror of 3.6 diameter, is situated in Aryabhatta Research Institute of Experimental Sciences in Nainital. And children, you should know that this is the largest optical telescope in Asia. So, till date, the largest optical telescope in Asia is situated in the Aryabhatta Research Institute of Experimental Sciences in Nainital. And previously we were having the diameter that was maximum 2 meters. Now the diameter has increased and it has become 3.6, which people are generally using. Children, please read the textbook, go through the chapters so your concepts will be becoming more clear. Remaining we are going to study in the upcoming videos. Good morning, children. Today we will be studying about the radio telescope. Many heavenly objects emit radio waves in addition to the visible radiations. We cannot see these radiations with our eyes. Hence, a special type of telescope is used to receive these radiations, and this telescope is known as a radio telescope. It is made from one or more dishes of a particular parabolic shape. As in the optical telescope, the incident radio waves are reflected by these dishes and converge at a focus. A radio receiver is placed in the focal point. The information gathered by this receiver is passed on to the computer, which analyzes it and constructs an image of the source. And this radio telescope is used for capturing the images, studying the atmosphere with the help of the radio waves. As we have already discussed that there are some heavenly bodies which emit the radio waves in addition to the visible radiation, and these radiations are not visible with the eyes because these are the radioactive radiation, these are radio waves. Hence, to observe this, we are having a special telescope, and that telescope is known as a radio telescope, and it is made from more than one dishes, and it gathers the information. The information is sent to the computer and processed, and in this way we are able to study about such objects which are emitting the radio waves rather than the objects which are emitting the light waves. Children, remaining we are going to study into the upcoming videos. Children, now we are going to study about the radio telescope. See children, in previous video we have studied about what is a radio telescope, and here I am sharing with you the image of the radio telescope. A large radio telescope called Giant Meter Wave Radio Telescope GMRT has been erected in the Narayangaon near Pune. It uses the radio waves having wavelengths of about 1 meter coming from the heavenly bodies to study those bodies. This telescope is actually a collection of 30 dishes, and each dishes have a diameter of 45 meter. It is called giant telescope as the arrangement of 30 dishes over an area which measures up to 25 km across is made in such a way that it works as a single dish having the diameter 25 kilometers. This means that the children GMRT gives the same data that we would have got from the telescope having a single dish of the 25 kilometer diameter. Children, the GMRT has been made by Indian scientists and engineers at the minimum cost. It is a world standard research facility. Scientists study the solar system, solar wind, pulsars, supernova, interstellar hydrogen clouds, etc. with the help of the GMRT. The scientists from all over the world come to India to use this facility in GMRT in Narayangaon. Children, please read the lesson, watch the videos, and if you have any queries, watch the videos twice so your concepts will be becoming more clear. Good morning children. Now children, today we are going to study about the telescopes in space. Now children, if you have read the chapter, you have come to the chapter, you might have come to know that there are the telescopes which are evolved in the reflecting telescopes, refracting telescopes, radio telescopes. Now there are telescopes which are in space also. Why? We will study now. The visible light and the radio waves emitted by heavenly bodies in space can pass through the Earth's atmosphere and reach the Earth's surface. So, the optical and radio telescopes can be erected on the surface of the Earth. However, these Earth-based telescopes present some problems in making good quality observations. The visible light coming from heavenly body has to pass through the Earth's atmosphere to reach the Earth's surface. During this journey, some of the light is absorbed by the atmosphere and the intensity of the light reaching the Earth's surface decreases. A second problem caused by the changes in atmospheric pressure and temperature. These changes can cause turbulence in the atmosphere, which in turn cause the light rays to change their path slightly and thereby shake the position of the image. Also, because of sunlight, we cannot use optical telescopes during the day. During the night, the city lights too many city lights and the cloudy weather can cause difficulties in observing the heavenly bodies. To reduce these problems, optical telescopes are situated on the top of the mountains and in uninhabited places. However, if we want to get rid out of all these above problems completely, we should place the telescope above the Earth's surface, above the Earth's atmosphere in the space itself. These problems do not exist in space, and thus the image obtained by the space telescopes would be bright and very clear and will remain at one place. The scientists have turned this idea into the reality, and in your upcoming videos you will be studying about the telescopes in the space. Now children, while studying the telescopes in space, in 1990 the National Aeronautics and the Space Administration NASA launched into a space an optical telescope. Okay, and this telescope is known as the Hubble telescope. It has a mirror which has a diameter of 94 inches and is orbiting the Earth at a height of 589 km from it. This telescope is still working and it has helped to make important discoveries. So children, one of the telescope which has been installed in the atmosphere itself is the Hubble telescope. The Hubble telescope was installed in the space in the year 1990 and it is still working and giving the information to the scientists in many ways. In 1999, National Aeronautics and Space Administration launched an X-ray telescope named Chandra in space to study X-rays coming from the heavenly bodies. Spherical mirrors, spatial mirrors which can reflect X-rays were used in this telescope. Chandra has given us very useful information about the stars and the galaxies. The telescope is named after the famous Indian scientist Subramaniam Chandrasekhar. So the name Chandra is given to the telescope in the honor of the scientist Subramaniam Chandrasekhar, who was an Indian scientist. So children, in this video we have studied about the telescopes in the space. Children, as we have studied about the telescopes, about the different types of the telescopes, we have studied about the telescopes in the space. Now children, once you are studying the space, and in India, if you are studying about the space, we should know the agencies which are studying, which are taking the data from the different types of telescopes, which are launching the different types of satellites, different types of vehicles. So we should have knowledge about that. So children, you should be proud to know that the ISRO is one of the leading organization, Indian leading organization, which has made tremendous discoveries in the field of space. And full form is ISRO is Indian Space Research Organization, and its headquarters is in Bengaluru. This institute was established in the year 1969 with the aim of developing technology for making and launching the artificial satellites. Till date, ISRO has successfully launched a large number of satellites. ISRO's program is foremost among the successful programs undertaken by independent India. India's progress in space science has played big role in national and social development. The INSAT and GSAT series of satellites support our telecommunication network, television broadcasting and meteorological services. It is because of them that the telephone, television and the internet services are available everywhere in the country. The AstroSAT satellite in this series is used exclusively for the education. The IRS satellite series is used for the monitoring and management of the natural resource as well as the disaster management. So you should know, children, that India has made tremendous progress in the field of space science, and ISRO is one of the leading Indian organization which is working in this field. Okay. Children, today we are going to study about the AstroSAT. In 2015, Indian Space Research Organization launched an artificial satellite called AstroSAT in the space. This satellite has ultraviolet and X-ray telescopes and detectors. Most of the satellite parts are made in India. Children, this satellite has an unique system having different kinds of telescopes in a single satellite. The Indian scientists are studying various aspects of universe, the data obtained with these telescopes. So children, AstroSAT is an Indian satellite, artificial satellite, and children, I am showing the diagram. This satellite was launched in 2015. One of the very important fact about this satellite is that most of its parts are made in India, and this satellite is having different types of or many different types of telescopes in this. So the use of it, that many different types of data, different types of information regarding the space is collected by the single satellite, and it is having a unique system. This system, you can say it is having a unique system because it is having the different types of telescopes on a single satellite. Children, here your chapter gets over. I am sending you the notes of this chapter in the PDF format. Kindly complete in your Science 2 notebook so that it will be easy for you to study for your upcoming unit test examination. Bye children, stay home, stay safe.